Hey guys, today we're talking about standard deviation of a normal distribution. All right, basically, we've been talking about different ways of viewing data in the last unit. Um, this is another way of taking that data and starting to analyze it a little bit more. So let's say you have all these data points. All right, this is kind of like a little histogram just made up with dots. You can kind of see in these um, two different histograms. One of them, the data is all kind of condensed. It's all close together here in the top. All right. So here would be your mean. And then all your data is pretty close. There's not a lot of deviation between the data points. They're all kind of close. Here, the data points all spread out. There's more deviation. All right. So this way to analyze the spread of the data we call standard deviation. All right. So now let's look at another one where we take a histogram and we make a curve. Right. So see there's two different suppliers here. There's the blue supplier and the red supplier. So supplier A is the blue one. Now notice if you look at the histogram for supplier A and you fit a curve to it, this is called a normal distribution. All right. And all the data is tight. All right. So that means that we have a low standard deviation or standard deviation. It doesn't deviate too much from the mean. So it's got to have a very small standard deviation. Where supplier B, which is in red, that has a larger standard deviation. We still get this normal curve where it curves up, curves back down, but the data is spread out, a larger standard deviation. And we're going to talk about what we can do with our standard deviation. Well, again, here's one more example. So if you hear low standard deviation, again, we have a high peak, not very spread out. High standard deviation, move myself up here. All right, it's more spread out data. Okay. The formula for standard deviation is kind of gross, but you're not going to have to use the formula. I'm going to show you how to do it just using a spreadsheet. You can also use a calculator. Watch the Inspire video if you want to see how to do it with a calculator. But to do it with a spreadsheet, which is fairly quick and easy, and I recommend it. You've got your sample standard deviation and your population standard deviation. So first you have to figure out, are you dealing with a sample size of your entire population, or are you trying to find the standard deviation of your entire population? And there's a small change in the math behind the two. Again, you don't need to know these formulas. What you do need to know is how to calculate the standard deviation or how to come up with a solution to it just by plugging numbers in. So what I did was I created a spreadsheet here. I just threw in some numbers here. We're going to do some actual example problems in a second. But here's a bunch of numbers. All right, 9 different values here. They're not even in order. All right. If you want to find the mean, all right, which is also called the average, all right, you just type in equals average. Gotta spell it right. Average. And you just click on column A and hit enter, and there's your average. Let's make the font a little larger on this. Oh my gosh, this thing's weird. Font. Let's go to 14. Boom. All right. Now let's say I want to find my standard deviation. Oh, standard deviation of a sample. All right. And drag this thing over. So if I type in equals STD, you can start to see there's standard deviation. If I want a sample, see standard deviation of a sample, so it's STDEVA. And then I'm just going to hit this first column. And there's my standard deviation of a sample. So if this is just a sample, if this is like 9 different items out of hundreds of items, this would be a sample. But if this was like monkeys in the zoo, and there were only 9 monkeys in the entire zoo, then that's my entire population. Then I can find my standard deviation of my population. I'm going to change it to population. And I just say equals STD. And again, you can see there's the population. So it's STDEVP. All right, parentheses, and then click on columns A's. And there's my standard deviation of my population, all right, which will come in handy because when you do your Khan Academy tonight, you're going to be asked to find the standard deviation of your sample, the standard deviation of your population, all right. Now, what can you do with these standard deviations? Well, you can look at what percentage of the population falls within certain criteria. All right. So one of the great things about these normal distributions is this area underneath this curve. You're given a lot of information about. So X bar, that is my mean. So my mean is this line, mean. All right. One standard deviation above the mean and one standard deviation below the mean basically tells me that the area underneath, the area is all the data points. All right. So all the data points inside here between one standard deviation above and one standard deviation below, 68% of all my data will fall within one standard deviation. That's 68%. That's fixed. All right. That doesn't change. It's always 68. It's called a 68, 95, 99.7 rule. It doesn't change. The mean will change, the standard deviation will change, but those percentages are constant. All right. For two standard deviations, so if you have your average, if you go two standard deviations above or two standard deviations below, the amount of data that will fall within that grouping will be 95%. And then three standard deviations all the data will fall, 99.7% will fall within three standard deviations of your mean. You could kind of compare this to when we did box and whisker plots. We knew that inside the box, 50% of the data fell within that box. This is kind of similar to that in the fact that we can figure out what percentage of data it falls within this. And then when we dive deeper into statistics, you can actually, if you wanted to figure out what like 1.5 standard deviations was, you can do that math. We're not going to do that in this class. We're just going to stick with these parameters. If it's either going to be one standard deviation, two standard deviations, or three standard deviations. All right. So let's go to some example problems and see how this stuff works out. Okay. There's the rule. There it is, 68, 95, 99.7. All right, so let's say you're given a problem like this. There are 4 monkeys in a zoo. Their ages are 4, 10, 12, and 16. What's the average age and the standard deviation of the entire population? So if I go back to my spreadsheet, I just didn't remember this. 4, 10, 12, and 16. So I'm going to change this to 4, 10, 12, and 16. I'm going to delete the rest of these. So I don't want them. And because it's a spreadsheet, it instantly solves everything for me. So my mean is 10.5. My standard deviation of my sample would be 5, but the entire population would be 4.33. And since this was the entire population in the zoo, that is my solution. All right. So there we go. So X bar is what we use for mean. Sometimes you use the Greek letter mu, but I don't think that comes up in these. And standard deviation is like a little sigma. All right. Now there are 20 monkeys in the zoo, and their ages are 4, 10, 12, and 16. So now it's the same thing, 4, 10, 12, and 16. We already plugged the 4, 10, 12, and 16 in. The mean hasn't changed. But now since this is just a sample, my sample standard deviation is 5. All right. And it's different because I don't know all of the monkeys, so I get a slightly larger standard deviation. All right. Now, supposing that data is normally distributed, the mean is 84 and the standard deviation is 18. Between what two values will the following proportions fall? 68% would be one standard deviation above and below. So you just take that 84 and you add 18, and you also take 84 and subtract 18. So when you do that, 66 to 102, 68% of the data will fall between 66 and 102. All right. And then for 95%, then it's 2 standard deviations. So you take 84 and you add 18 twice, and take 84 and subtract 18 twice. And when you do that, you get 48 and 120. That means that 95% of all the data will fall between 48, and 120. Then you do 3 standard deviations to figure out the 99.7. All right. I'm going to scroll down to the bottom because this is actually kind of helpful, because sometimes you'll get problems where they ask about 1 standard deviation above and 2 standard deviations below, how much of the data falls in there. So that's 68%. If you break it in half, it's going to be 34% and 34%. All right. And then if you take the 95%, which is 2 standard deviations, oh yeah, here's the mu right there, which is another way to call the mean. If you have like 1 standard deviation above and 2 standard deviations below, what percentage of the data? You just add these percentages together. So that may come in handy when you go to do some of the homework, when you do the empirical rule problems. And hopefully that is helpful. You can watch more videos online if you'd like more explanations of this. But that's all I got for you. I got to go eat dinner, and so do you. That's it. Goodbye.